Welcome back! Today we are integrating the rocket launcher into our advanced weapon component using our modular data table workflow. Before we dive into the blueprints, a quick housekeeping note on visuals. For the purposes of this walkthrough, we are going to reuse our existing hipfire animation montages and sockets. I imagine that by the time you introduce heavy ordnance into your own project, your animators will provide you with custom over-the-shoulder poses or specialized weapon grips. For this implementation, we are keeping our logic clean and strictly focusing on proving that the back-end architecture tracks, scales, and handles heavy weapon data perfectly. This is going to be a two-part process. In this video, we are setting up the weapon infrastructure and verifying our socket accuracy using standard line trace debug lines. In the very next video, we will build the physical, explosive projectile blueprint and drop it right into the slot we're creating today. Let's get to work. First, let's prepare our assets. Open up your rocket launcher skeletal mesh. Simply go to the top bar of your skeletal mesh viewer, click Make Static Mesh, and export it directly into your Weapons folder. With the skeletal mesh still open, we need to tell the system exactly where the line trace or the future rocket projectile should originate. In the skeleton tree, right-click and select Add Socket. Name this socket Muzzle, exactly matching the naming convention used by your other weapons. Move the socket so that it sits cleanly just in front of the exit barrel, ensuring the forward axis faces directly outward. Save and close the mesh. Now, let's register the weapon with our primary data table. Add a new row and name it Rocket Launcher. Remember, if you are working in Unreal Engine 5.7, spaces in data table row names are completely invalid and will cause errors, so keep it as one solid word. Let's populate the row variables. Set the weapon type and weapon class to their respective weapon categories. For the projectile class, we are leaving this on its default for now. We will replace this single variable with our custom rocket actor in Part 2. For physical placement on the character's body, we will leverage our modular design and reuse the existing shotgun socket path. Under Attributes, turn the damage amount up significantly and assign a large value to the explosion radius field to prep for the rocket's behavior. Input your maximum ammo capacities, reserve bounds, and the clean display name. Down in the cosmetic and asset slots, drop the shotgun data asset directly into the default animation slot to map our hipfire structure. Finally, assign the skeletal mesh, the static mesh we just generated, your explosive fire sound cue, the reload cue, and your chosen muzzle flash particle effect. Next, we need a physical input to draw the weapon. Open your character blueprint and navigate to your weapon selection logic. Grab your last numeric input chain, duplicate the key press event and the select weapon node block, and wire them in. Make sure to change the integer index on the select weapon node to 5 to represent our new slot, and change the input key to 6. Compile and save. To make sure the character maintains their stance when holding the weapon, open up your animation blueprint and locate the EWS_weapon_type logic. Right-click and add the rocket launcher to both. Duplicate the idle hip and rifle idle nodes to them and compile. Jump into the Animation Preview tab, switch your preview variables, and confirm that the skeleton transitions cleanly into the hipfire pose without breaking. All the core connections are built. Now let's run a live test. Select the weapon spawner actor placed in your level. Go straight to the Details panel on the right, locate the weapon name string field, and type in Rocket Launcher, making sure it exactly matches the text and casing of your data table row. Let's hit play. Walk up to the rocket launcher and get the weapon. The weapon appears cleanly to the hands. And when we pull the trigger, you can see the red debug line trace shooting out of our custom muzzle socket. Our core backend infrastructure is tracking 100% correctly. Now that the tracking works, join me in the next video where we build the physical, explosive rocket projectile blueprint from scratch. See you there!